Relate intersection of three planes with their normals. How can you predict from the normals that the xy plane, yz plane, and xz plane will intersect at a point? Now, well, this was very obvious. We have been working with this R3 coordinate system for such a long time now, and now we have been asked a question and says, well, this is my x-axis, right? Let me redraw and have a closer look at it. This is x, y, and z. The question here is that we have xy plane, that is the xy plane, and then we have yz plane, this is my yz plane, right? And then we have xz plane, which is this plane. The question is, how can you predict that the normals, from the normals of these planes, that they will intersect at a point? And of course, they intersect at a point. We know it. Now, the thing is, here's a communication question for you. How can you say that they intersect in a point? Well, we can see it, but well, you have to prove it algebraically. That is the question. Now, the idea here is that we have done in this set of videos how to predict intersection of planes from studying their normals. So let's look into their normals now, okay? So what is the normal for xy plane? So the xy plane normal is shooting out and it is in the direction of z, right? So we can write that normal. So we say n1 as normal to xy plane. I could write this as 0, 0, 1, correct? Yes. And for yz plane, the normal will be coming out along the x-axis, correct? So let me call that as n2. So n2 is coming along the x-axis, so it's 1, 0, 0, correct? And normal n3 is for the xz plane along the y-axis, correct? So that will be 0, 1, 0. So these are the three normals for these three planes. Now we learned one thing, that intersection at a point is possible if scalar triple product is not equal to 0. That means we need to prove that n1 dot n2 cross n3 is not equal to 0. If it is not equal to 0, then they intersect at a point, correct? That is what we have to prove. So in short, that is what we want to prove. So let's figure it out. So what is n1 dot n2 cross 3? So you can do cross product of n2 and 3 and then do dot product with n1 and get your answer, right? That's one way of doing it. Or let me just make this matrix so that we simplify this job. So we say, okay, n1 is 0, we write 0, 0, 1, and this is 1, 0, 0, and then we have 0, 1, 0. So if we do scalar triple product, that means it is 0 times this, right, which is 0, correct? So let me write it down. So it becomes 0 times something, which is 0 minus 0, right? Okay, and then with this we get minus 0 times 1 times 0 is 0, and 0 times 0 is 0, so minus 0, correct? And then we have 1 time 1 is 1, so we at least got something here, minus 0, something here, minus 0. So effectively what do we get? 1 times 1 is 1. But most important thing is that this is not equal to 0, correct? Now that is the answer, correct? Now since, therefore you should remember, since scalar triple product is not equal to 0. What is the point of intersection? One point of intersection, correct? Planes, that means three planes, right? Intersect at a point, right? We call this point origin. But that is huge example, right? Looks so simple and obvious, but it proves a very important point for us. I hope you understand from here, and then the other videos which we have discussed makes a lot of sense for you. And I hope this knowledge which you've gained helps you to make a correct choice in multiple choice question or eliminate few answers which should not be correct, is it? So either way, it should help you. Thank you and all the best.